Hello, Professor. This is Sai Raghvendra Talapalli. So today I'm going to submit the final report for my course 5550, which is deep learning with data. So, my agenda is to cover for my project, which is an introduction, architecture, dataset and workflow, and the results and the conclusion. So first I'll cover the introduction with the deep learning with the data. So deep learning, which is a subset of machine learning, which concern and follows with the algorithms that were inspired by the structure and function of the brain. So which is called as artificial neural networks. When we see the brain, which consists of the neuron structures, which has multiple zigzag informations with the different types of connections with different neurons, right? The same way we can consider here for the deep learning. Basically, the deep learning concepts are used to teach the machines, which we as a humans will comes as a natural thing. So whatever the information which we have, whatever the data which we have, that we are feeding into the machines and that we are treating and teaching to the machines, which they can they can understand, they can gain the knowledge from the data, and which will give the processed output. So the computer models in the deep learning, we have different types of models where we can taught, or we can we can learning, we can give the information to the system by running the classification, uh, which could be act as an taking as an input for an image or text or a sound or a video as an input. In deep learning, we have different types of neural network models. We have convolution neural network, recurrent neural network, and artificial neural network. Into the architecture, um, basically, I would cover the convolution neural network. That is what the model which I preferred. So I used to tell the architecture very informatical way. So for recurrent neural network and artificial neural network, I used to give the brief architecture overview. So in both the architecture, so we have a input layer and output layer. So in between that, we have different types of hidden layers. So the hidden layers, it could be depends on the model owner. So they can able to use n number of hidden layers, where we have the different types of zigzags and neural network connections. The same way as for the artificial neural network, it could be somewhat folding and unfolding will be happen here. So the different type of model. Coming to the convolution neural network. So here we used to have the different types of classes for the deep learning, deep neural networks. For the different types of classes, most commonly we used to apply for the analyzing visual imaginary. For convolution neural network, usually we applied for the images. So for example, we have the image and we can reduce each part, whether it could be we used to reduce the image size, and we can learn the information whatever we have. Basically, it would be the digital image processing used to happen in the normal technique, right? So the same way we used to follow here. We have different types of layers here: convolution layer, the pooling layer, and the fully connected layer. Every layer we used to reducing the size, and basically in the convolution and the pooling we used to take the edges and corners. We used to the pooling is kind of matrix level, matrix multiplication kind of thing. In the data set, I used to take in the data set from the Kaggle, which consists of three folders, which means the trying, test, and validation folders. And basically the data set consists of the chest X-ray images of pneumonia. We used to have the pneumonia pictures of lungs. So the pneumonia will be affected based on the virus or a flu. It could be a breathing problem. So basically, this data set consists of the images which consists of pneumonia or the original normal thing, normal one. So the pneumonia, if a person has a pneumonia, it could be affected for the both the lungs, or either it could be affected for one lung or both lungs. So CIFAR 10 data. So the part one, the part two, right? The part two. We have in this data set we have 60,000 images, and we have their image size as well. So basically, the convolution neural network will have that will basically divide into different types of classes. So here in these images, right? So we have divided into 10 classes with 6,000 images per each class. The 60,000 will be divided into 10 classes. Well, each will be 6,000. There are 50,000 training data and 10,000 testing data. So here I have used GCP Cloud to connect the remote virtual server, and I have used the Jupyter Notebook to access the data sets and to run the model in the Python. So in the part three, we have different. I have divided into different types of parts to build and to provide the report. So here I would cover the build, train, and test for the CNN model. And here we have the input, and we have two convolution layers, convolution layer 1 and convolution layer 2, and pulling layer 1 and pulling layer 2, and we have one flattened, and then we are connected to different output sectors based on the layers. So these are the results which I got it. So here we can see the step size from 0 to 4,900. I mean 5,000, it could be 4,900. Based on the step size, we used to see the accuracy. So if it is a 0 size, we have 0.1. If it is 100, 0.4, 200, it's 0.4. If you increasing the step size, the accuracy will also increase. For example, for CAF 10 dataset, for 4,900 step size, we used to get the 0.68 around. I mean, it could be based on the things. If it is like 5,000 we have used here, so the test accuracy would be the 62 when I ran the Python model. So when I compared with the CIFAR 10 data and MNIST dataset, the CIFAR dataset consists of this number and this number, and we used to see the comparison. This is the architecture diagrams for both the models, for both the data sets. I mean, sorry, for both the data sets. And these are the test comparison results. So if I see the accuracy is more on MNIST. So when we compare with the results, we can see the graphs here. We can see the more accuracy in the MNIST. So when we compare the results, so as we are using the same architecture for the both datasets, accuracy will change between, because the MNIST dataset will have, when we see it's a colored images, and we have used the same filter size for the both. And if you want to see the gap between the two test results, we can change the filter size. So for MNIST, the model was trained for 5,000 steps, but the batch size is 50. And we have 100 steps for that. And the model, we have CIFR 10 model consists of 5,000 steps, but the image batch size is 100. So if it is, if we are increasing, right, so after the 10 100 steps, right, the test data is happening. So if we consider more batch size, then the learning rate of the model will be high. So if we increase the batch size, the learning rate will be very high, and there is a chance of getting the lower accuracy. I mean, if you reducing the batch size, accuracy will be more. I feel like the dropout layer probability value matters the lot for accuracy. So when I redesign the architecture for CFR data, so instead of using two convolution layers, I have used three convolution. So if we use the layers, I mean, if you increase the convolution layers and if you increase the pooling layers, so I try to see the results, how it look like. So after increasing after redesign, right? So I increased layers of that. So for the original model, I used to get the accuracy of around 68, and the redesigned one, I got the accuracy of 72%. I can say that I can understand that if we add more layers, then the model will learn more, and there is a chance of achieving good accuracy for the validation data, which will not make the model leads to overfitting, because if we see the overfitting is high, accuracy will be very less. It will reduce the overfitting for that. So I can conclude that from the results of redesigned one and the original one, I can conclude that. So the projects, when we compare with the both models, right, original and the redesigned one, so the approach is same, and I have used the same architecture for that. But the performance of the model will vary based on if we increase the number of layers for that. So apart from that, so still we can improve the performance when we pre-train the model or performing the hyperparameter tuning. So if you tune the model, or if we train the model in a better way, we can improve the results, and we can get the good accuracy for that. So such as, I mean, the other features where we can extraction methods can be used as transfer learning to extract features, and we can get the good accuracy. So thank you. This is the final project submission which I did. Thank you, Professor. So I have learned a lot from this class. So the deep learning models and techniques, how we can use the cloud from our virtual machine, remote virtual machine. And thanks a lot. I have learned a lot from this class. Thank you. Thank you very much.